Hello everyone, I'm Raksha, a computer science BTech student. This is my third presentation of task 3 and today we are looking deep into the architecture of the liquid galaxy controllers. Now, when most of us get started in this ecosystem, we usually start with this very specific or the optimistic mindset, like we write our code in a quiet room, we test it on a private network and we assume that because it worked once, it will work forever. I used to call this the lab mindset. Isn't that it's just the feeling of satisfaction you get when you hit a button on your tablet and the KML loads onto the rig, and you think that yourself that okay, I've mastered this. But the reality of the distributed system is much more complicated than the usual successful test in lab. Liquid Galaxy isn't just a single application; it is a cluster of machines working in synchronization. The moment you take your controller out into the real world, whether it's a crowded exhibition or a classroom or a public demo, everything changes. I remember my very first public demonstration, like I was so confident in my code, but then the room got crowded, the local Wi Fi started to struggle, and my application just stopped. I didn't crash with a big error message. It just sat there, frozen, waiting for a network response, like that was never going to arrive. It was an incredibly humbling experience. Like it made me realize that being a coder is about making the things work, but being an engineer is about making the things survive. Today, I'm not here to show you like how to write a simple script to move a camera. I want to talk about how to become an architect, so that we are going to look at how to build the controllers that are resilient, predictable, and professional, even when the network is failing and the hardware is under heavy pressure. We are moving beyond the basics to build the systems that simply refuses to break. Now, in the world of liquid galaxy, we need to completely change how we define the word broken. Most people think an app is broken only if it crashes or closes or disappears from the screen, but that is a very narrow view of failure, I say. And a big and distributed system like liquid galaxy, broken usually looks like a loss of truth. Imagine your tablet says moving to London, but the big screens behind you are still stuck looking at a blurry image of New York. The app didn't crash, but it lied to you. The connection between the controller and the reality of the rig is gone, and that is a total failure. Or imagine yourself, you tap a button and nothing happens for 3 seconds because of a slow network. Your natural instinct is to tap it again. Now the rig is trying to process two heavy commands at the same exact time, and it starts to stutter, a lag, and looks unprofessional. I once saw a rig get so confused by repeated commands that the three screens started showing different parts of the world, and it was totally a big mess. Then the app was still running, but the system was broken because it was no longer predictable. So the resilience isn't just about staying open, it's about making sure that every single thing the user sees on the tablet is exactly what is happening on the screens and keeping the truth alive even in a total chaos. Now, so the biggest invisible enemy we face in this field of is that SSH connection drop. Think of SSH as a phone line between your tablet and the master node. We usually assume that once we start the call, the line stays crystal clear and until we decide to hang it up. But in the real world, the line is more like a thin wire stretched across a canyon in a vents room. If you are sending a heavy KML file and the Wi Fi signal drops just for a second, the phone line is cut. But here is the problem, your tablet does not always hear the click of the hang up. It stays there holding the phone to its ear and waiting for an answer that is never coming back. So the users sees a loading spinner that never stops, and they quickly get frustrated. Like, yeah, I used to blame the master node for being slow or dumb, but I was wrong. The problem was that my code was too trusting, and in engineering, you have to realize that a connection is just a temporary state, not a permanent fact. The resilient controller must be a constant, and it should always be asking itself, are we still connected? Is the rig still listening? If the answer is no, the controller should stop waiting immediately and start fixing the problems. Silence is the worst way to handle a failure because it leaves the user feeling helpless and We must detect the drop the moment it happens. Now, when I was a beginner, like I was an optimist, I would write a code that sent a command and then immediately showed a bright success on the screen. I was basically saying I sent the letter in the email, so I am sure that it was delivered perfectly. But that is a very dangerous way to build a professional tools. Just because your tablet sent a command does not mean the master node was actually able to finish it. Maybe the rig ran out of the storage space. Maybe there was a tiny typo in the file name that you tried to load. Now, if your controller does not wait to hear the final result from the rig, you create a reality gap. Your tablet thinks everything is great, but the rig is actually struggling or doing nothing to all. To fix this, we have to move from assumption to the validation. We need to look at that the exit codes, which is the rig's way of saying yes, I finished, or no, I failed. We should only show that the success message when we have the actual proof in our hands. Validation is like checking your recipe before you leave a store. It's the only way to make sure your app and your rig are always telling the exact same story, which is the foundation of a user trust. Now, KML files are what give the Liquid Galaxy its amazing power, but they are incredibly picky about how they are written. KML uses a language called XML, and if you miss even one tiny bracket or a slash, the whole file becomes poison to the system. I once worked on a project where a user typed a special symbol like an ampersand and into a search bar. That one single symbol broke the entire XML structure of the file I was sending. So the master node didn't tell us like what was wrong. It just ignored the file because it could not read at all. So my app thought it had succeeded, but the screen stayed frozen. We spent so much time looking for a big network bug when the problem was just one tiny and invisible character. So that taught me that the controller must be a bouncer at a club. It shouldn't let any data through the door unless it is clean, safe, and perfect. We need to check every coordinates to make sure that they are real numbers on the earth. We need to check names to make sure that they don't have the illegal symbols for XML. And if we catch the garbage on the tablet, we keep the rig healthy and running. Clean data is the only way to ensure a smooth, professional looking demo that does not stop for mysterious reasons. Now, timing is a very tricky and misunderstood thing in a distributed systems like Liquid Galaxy. A lot of developers use a wait command, basically telling the app to sleep for 2 seconds. They think that 2 seconds is plenty of time for the rig to load a map. But what happens when the rig is extra busy that day, or when the network is crowded with other devices? Those 2 seconds pass and your controller blindly sends the next command while the rig is still struggling with the first one. Now, the instructions are crashing into each other. This is exactly why you see the screens flicker or the camera jump suddenly from one spot to the another. It looks messy, glitchy, and unprofessional. Instead of using a fixed clock, a resilient controller uses states. We shouldn't have moved to step 2 just because the clock reached 0. We should only move to step 2 when the rig sends an explicit signal saying I'm finished with the step 1 and I'm ready to move forward. You have to build your code to be patient and observant. It's need to adapt to the speed of the rig in real time, whether the system is running fast today or having a slow or heavy afternoon. This handshake between the tablet and the rig is what creates that the smooth and buttery motion we all want. Now, we all want to be a persistent and try again when we fail. But in the world of networking, retry logic can be like a hammer. If you use it too much or too fast, you end up breaking the very thing you are trying to fix. Now, in many first designs, like in my first designs, my app would try to reconnect the very millisecond it lost the signal. If the Wi-Fi signal flickered for 5 seconds, my app would try to reconnect for 100 times in that tiny window. It didn't help the connection at all. Instead, it flooded the router with junk data and made the tablet get hot and drained the battery. It actually made the network problem much worse. I learned a much better way called exponential backoff. It's simple but brilliant rule. If you fail, wait 1 second. If you fail again, wait 2 seconds, then 4, then 8, then multiply. This gives the network and the master node breathing room to fix themselves and clear the air. Also, you have to know when to finally quit. If it fails for 5 times, you must stop and tell the user, I'm having a real trouble here. Please check the router. And a small controller knows that when to be persistent, when to stop, and asks the human help. This balance is what makes an app feel intelligent rather than broken. Now, how do you keep your app from getting confused when five things are happening at once and you need a strong state architecture? Many beginners try to manage their app with a bunch of simple S or no switches like is coding or is connected. But as your app gets bigger, these switches start to fight with each other, and you might end up with the zombie state where your UI think it's loading, but the network layer already knows it's disconnected. To fix this, we used a finite state machine. This is just a way of saying your app can only be in one mode at a time: idle, connecting, busy, or error. If the app is in the busy mode, it physically won't let the user press the button again. And this removes all the confusions and the overlap. And it makes the app behave like a professional tool that knows exactly what is doing and at every microsecond. So, when your app's brain is organized into these clear states, your code becomes much harder to break and your debugging becomes 10 times easier because you always know exactly where the app is logically. Now, the master node is a powerful machine, but we have to remember it is not a superhero. It has a physical limits. It is incredibly busy rendering the 3D buildings and handling the network traffic and managing the file transfers at all the time. So if we send too heavy commands too fast, we can actually overwhelm it. I've seen the controller send 60 camera updates every single second, and while a user moved a slider on the tablet. So the master node could not keep up with that much data, so it started a lag and stutter. So the developer thought the rig was broken, but it was just choking on too much of information. We need to build a load awareness into our controllers. We use a technique called throttling to limit how many commands we send. If a user moves a slider quickly, we only send an update every 100 milliseconds. By respecting the hardware and giving it a space to breathe, we get much smoother visuals. And a resilient controller does not just push the system as hard as it can, it manages the system's energy and resources so it can perform at its absolute best for the audience. Professionalism is about restraint and control. Now, you don't truly know how strong your app is until you have tried to break it on a purpose. In the beginning, I only tested my code when the Wi-Fi was perfect and the rig was fresh. Then that was a big mistake that led to failures later. Now I practice a chaos testing. I intentionally create a disasters to see what happens. I turn off the Wi-Fi for a while, then it's a halfway through the transfer. I type in a fake coordinates that does not exist on the planet. I restart the master node right in the middle of the complex camera command. Every time I do this, I find a new hole or a new bug in my code. And finding those bugs is a wonderful thing. It is much better for me to find a bug in my office than for a high profile user to find it during a big presentation. So stability isn't something that happens by accident. It's about being ready for the things to go wrong. You have to be your own toughest critic. Breaking your own work over and over is the only way to make it truly unbreakable. When you have seen your app survive every disaster you can think of, and you gain a level of confidence that you can't get any other way. Now, user experience about more than just a pretty colors and nice fonts. It is actually a defensive shield for your code. When a user presses a button and nothing happens immediately, they get nervous. Their first instinct is to tap the button again and again and harder and faster. This panic tapping can crash a system that is already running slow. This is why immediate feedback is so important, that the moment a button is pressed, it should instantly change color, vibrate, or show a spinner. The UI must tell the user, I heard you and I'm working on it right now. If there is a real problem, we should use a clear and a simple language. Instead of showing a scary technical error code like error 500, we should say the connection is a bit slow. I'm trying to fix it. If the user stays calm because they feel informed and they feel interact with the app in a calm way. A well designed UI protects the code from the user, and it protects the user from feeling frustrated. Clear communication is the key to resilience any distributed system, and it's about managing the humans as much as the machine. Now, if one part of your app fails, the entire app shouldn't just die or close. This is a strategy called graceful degradation. Imagine your controller is like a big ship with many rooms. If one room gets a leak, you don't let the whole ship sink. You just shut the heavy door to that one room, and the rest of the ship stays dry and keeps move forwarding. Then we should build our controllers with the same philosophy. If the connection to the rig drops, the user shouldn't be locked out of the whole app. They should still be able to look at their saved places, check the help section, or change their local app settings while the network layer tries to fix the connection in the background. We keep the network logic completely separate from the local logic. This ensures that the app stays useful and responsive even when the things are going wrong with the hardware. So graceful degradation is about accepting that the small failures are inevitable and making sure they don't turn into the total disaster. It's about staying helpful even when you are limited. Now, let's talk about the guts of your application. To build a resilient controller, you need a principle called separation of concerns. This is just a simple rule. Keep your toys in different boxes. In a beginner apps, the button, the math, the network code, they all are mixed together in one giant and a messy file. This is a nightmare because everything is tangled. If you have a problem with the Wi-Fi, it might crash your whole UI because they are too tightly connected. So instead, we divide the app into clear layers. The UI layer only cares about the buttons and what the user sees, whereas the network layer only cares about SSH and data packets. They talk to each other through a middleman or a controller layer. This means that if the network has a problem, the middleman catches it and tells the UI, hey, just show a spinner for a second while I fix this. Because they are separate, the UI stays stable and smooth even when the network is messy. This architecture makes your app much easier to fix and much easier to upgrade and almost impossible to break completely. So the clean boxes make for a clean mind and clean code. Now, sometimes a system does not crash, it just hangs. This is a silent failure. The connection is open, but the master node has stopped answering for some reason. It's like someone picked up the phone but is just standing there not saying a word. In a normal app, your controller would just sit there waiting forever. The user thinks the app is frozen and they get frustrated and close it. To fix this, I use a watchdog. It is a simple background timer that starts every single time I send a command. If the command takes longer than a reasonable amount of time, say 10 seconds, the watchdog says, hey, this is taking too long, something is wrong, and it does not ask for permission, it just acts. It resets the connection, cleans up the mess, and tells the app to try it again. Without a watchdog, your app might stay frozen forever. This little timer ensures that the app always stays active and responsive. Even when the rig is having a silent failure, it's like having a supervisor who makes sure nobody is sleeping on the job and just keeping the demo moving on no matter what. Yeah, coming to the next slide, here is a big word that is actually very simple to understand, that is idempotency. A command is idempotent, like if doing it 10 times is exactly the same as doing it once. Like think about the mute button on your TV remote. If you press it once, the TV goes silent. Like if you press it 10 more times, the TV is still silent. But that is an idempotent action. In Liquid Galaxy, we should avoid relative commands like move a 10 steps right. If the network lags and the command is sent 3 times by mistake, you move 30 steps and end up in the very wrong place. So instead, we should always use the absolute commands like set positions to 90 degrees, because even if that command is sent for 10 times, the rig stays in the exact same point. This protects us from network glitches and accidental retries and users who tap the screen too much. And by designing our commands this way, we make sure that the final result on the big screen is always exactly what we intended, regardless of how many times the message had sent to the rig. Absolute states are much safer and more resilient than the relative changes that is very noisy in a network environment. Now, the data validation is like having a very strict bouncer at the door of your network. Before any piece of information like a coordinate or a file name is allowed to leave the tablet, we must check it thoroughly. I have seen rig-wide crashes caused by a tablet sending a coordinate that was not a number, or a name with symbols that master nodes simply could not read. When this poison hits the data, the big screens, the whole visualization client can stop. So to prevent this, our controller needs a strict validation layer. We must check every number. Is the altitude actually between the negative 90 and to the positive 90? And we must check every string. Is it safe for XML? And by catching these mistakes on the tablet, we stop them from ever reaching the master nodes. And it is 100 times easier to show a small error message on a tablet than it is to reboot a 3-screen rig in front of a live audience. Strict validation is about being a defensive programmer. You assume that the mistakes will be made and you will stop them at the gate before they can do any damage to the larger system. If something goes wrong during the presentation, you need to know exactly why it happened. Without data, you're just guessing, and guessing is not just professional. This is why I use telemetry. It is like the black box flight recorder on an airplane. My controller keeps a secret diary of everything it does. It records the exact millisecond a command was sent, how long the rig took an answer, and an error codes that came back from the system. Later, if a user sees the app acted strange, I don't have to wonder. I can look at the diary and see exactly what happened at specific time. I might see that the Wi-Fi signal dropped to 10%, or that the master node was too busy processing a heavy KML. Telemetry turns a mystery into a lesson. It helps us to find patterns in the failures and fix them so they are they never happen again. A resilient controller does not just recover, it explains itself. Like having this data makes you much better an engineer, because you are solving the real world problems based on cold hard facts and not just feelings or just by guessing it. Now, when people start out, they usually build scripts, or small pieces of code that do one specific task. Scripts are fine for a small school project, but they are very fragile and hard to grow. If you want to build something professional, you need to build a platform. A platform is a strong, reusable foundation. It is a system that handles all the boring but difficult stuff automatically. The things like connection management, error handling, and the data validation. So I spent a lot of time building my core engine first. Once that engine was stable and bulletproof, adding new features became easy and fun. If I want to add a new navigation mode or a new map layer today, I don't have to worry about the Wi-Fi or the SSH connections, because my platform already handles all of that. Building a platform means you stop solving the same connection problems over and over again, and it allows you to focus on the art of the visualization and the user experience, knowing that the foundation underneath is rock solid and completely reliable. Now, the biggest change in my work wasn't a new line of code or a new framework. It was a change in my mindset. I moved from a demo mindset to a production mindset. In a demo mindset, you hope for the best. You think, I hope the Wi Fi is good today and I hope the rig is fast. But it's a mindset based on luck. In a production mindset, you prepare for the worst. You expect the Wi Fi to drop. You expect the user to click the wrong button. And you expect the master node to be slow. When you design for a failure, you stop being afraid of it. Your controller stays calm because you have already written a plan for every disaster you can imagine. So this is the difference between a student project and a professional, a world-class system. A production grade controller does not like just work; it survives. It stays stable because the engineer behind it was honest about how messy the real world is. This shifting is in thinking is like what turns a coder into a system architect, and it's what will make your work stand out in the professional world. Now, to wrap this up, building liquid galaxy controllers that do not break is about like much more than just the code you write. It is about the architectural discipline. It involves the anticipating instability, checking every piece of code, and building a strong foundation. We have to remember that the things will go wrong. The network will get fluctuate, and the hardware will sometimes be slow, and the users will be unpredictable. But a resilient controller acknowledges these realities and handles them before they become a problems. By using the tools we talked about today, like the watchdog, the state machines, and the data validation, we can handle these problems gracefully and professionally. Liquid Galaxy is an incredible platform that let us see our world in amazing ways. Like it deserves the controllers that are just as strong and stable as the screen they drive. Instead of just focusing on making the things move, let's focus on making things stay stable. When your controller keeps running smoothly while everything else is chaotic, you have achieved true engineering maturity. Thank you so much for your time, and I would be very happy to respond for any of your questions or the issues on this topic in the community channel.